Hello everyone, welcome back to my channel again. So in this video, let's continue the model question paper of electric circuit analysis for video students, especially for electrical and electronics engineering as well as to ECE students. So in previous videos, I explained about model A1 question and solutions. So in this video, without wasting time now, let's go for model A2 set as unit 2 questions. So unit 2, which comes under question number 3 and question number 4, so that they asked you to state and explain Thevenin's theorem. So at the same time, I wanted to tell you some important questions that you can expect from module 2 also. So everyone are only practicing numericals instead of a theory part. So it's kind of request you to look into the theory also, because many of the times they will ask one theory questions like state and explain the theorems. So for electrical students, we'll be having four different theorems called as superposition theorem, Thevenin's and Norton's theorem, as well as maximum power transfer theorem. So in the maximum power transfer theorem, we'll be having one derivation that you need to practice. That is also a theory part. If you practice a state and explain Thevenin's theorem, Norton's theorem, superposition, as well as maximum power transfer theorem, you can expect maximum of 8 to 10 marks in the examination. So that don't forget that now. So coming back to this model question paper now, just see state and explain Thevenin's theorem, which comes under CO2 and PO1. You'll get, the marks they asked it for 8. Statement you need to write. Statement you need to practice it very well. Statements in brief, it's written here. Suppose if two or more voltage or current sources are acting simultaneously in a linear network. Okay, so you need to find either current or else a voltage in any branch, that is algebraic sum of the currents or voltages that would be produced in it or across it when each sources acts alone and all the independent sources are replaced by their internal resistances. If that independent sources are not having the internal resistances, the voltage source which will be act as a short circuit and a current source which will be act as open circuit. So that you need to write for the step, so that you can observe here, if two or more voltage or current sources are acting simultaneously in a linear network, the resultant current in any branch is the algebraic sum of the currents that would be produced it in when each source acts alone and all other independent sources are replaced by their internal resistances. If it is not having internal resistances, the voltage source which will be act as short circuit and current source which will be act as open circuit. Explanation. So for the explain, state and explain. For explanation, so you need to take a one simple circuit and you need to mention the resistors and voltage sources. So my suggestion is to take a circuit which consists of only two sources. Either it is a two voltage source or two current source, or one voltage, one current source, like that, independent. So now let us consider. So I'm considering this circuit which has two voltage sources, that is V1 and V2, and it is having the three resistors, say it as R1, R2, and R3. If they asked you to find current flows through R3, so now we need to find current flows through R3. Current flows through R3. So now it is having more than one source. So that I3 you need to find with the help of superposition theorem. So you need to consider one voltage source and other independent voltage source which is replaced by its internal resistance. But this V2 is not having any internal resistance, so that you have to make that as a short circuit. So that next step you can see here. Step 1, take source voltage V1. So you are taking voltage source V1, so that you need to make V2 as 0. That's why V2 that will be act as short circuit. V2 is short circuit. Only V1 is acting alone. So in this case, you need to find current flows to R3. So for the first case, I3 that will be act as I3 dash. So that this I3 dash, which is given by, you need to find this value I3 dash. Okay. So you can see branch currents I1, I2, I3. So I1, I2, I3 dash. You need to find the value of I3 dash. So this I3 dash, if you are taking this as I1 and this as I2, so this I3 dash that will be nothing but I1 minus I2. That is nothing but I1 minus I2 is nothing but I3 dash. Because I1 is also flowing downward, but I2 is flowing upward, so that I3 dash is nothing but I1 minus I2. So I need to find the value of I1. So like how we'll find the value of I1? I1 is nothing but the total source current, this one. So just simply applying Ohm's law. So we know that I is given by V by R, so that I1 or else I1 dash, which is given by total voltage V1 divided by R equivalent. Whereas this R equivalent is nothing but this R2 and R3 are in parallel, and which is series to R1, so that R equivalent is nothing but R2 into R3 divided by R2 plus R3, and R1 is series, so that plus R1. So you will be getting I1 dash equals V1 divided by R2 R3 plus, sorry, R2 R3 divided by V1 divided by R2 R3 is parallel, so that R2 into R3 divided by R2 plus R3, which is series to R1, so that plus R1. Similarly, you need to find the value of I2 dash. So if you want to find the value of I2 dash, once after knowing the value of I1 is simply applying what current divider. What it says, I2 dash is nothing but total current is nothing but I1 dash is a total current into opposite resistor. So opposite resistor is R3 for this I2 dash. So that R3 divided by R2 plus R3. So once after knowing the values of I1 dash and I2 dash, then you will get the value of I3 dash, that is I1 dash minus I2 dash. When V1 which is acting alone, by considering other source as 0, that is V2 voltage source is there, 0 is nothing but a short circuit. Similarly, step 2, what you are doing, you are considering V2 and V1 become short circuit. So that let's consider, take source V2 alone and replacing V1 by short circuit. Okay, so that V1 is short circuited and you will be considering V2, then you need to find current flows through R3, that is nothing but I3 dash double dash, second case. That is also again, you know the value of I1 and I2, it is nothing but I1 minus I2 again. I1 double dash minus I2 double dash. So I1 double dash, to find the value of I1 double dash, you are applying current divider. That is nothing but I2 double dash into R3 divided by R1 plus R3. And to find the value of I2 double dash, so I2 double dash is nothing but total voltage V2 divided by R equivalent, where R equivalent is nothing but R1 is parallel to R3 and this combination is series to R2. So that R1 into R3 divided by R1 plus R3 plus R2. The same thing you can see here. The branch currents I1 double dash, I2 double dash, I3 double dash. I2 double dash is nothing but this current. I2 double dash is V divided by R equivalent. That is nothing but V2 divided by R equivalent. whereas R equivalent you can observe here, this is R equivalent, so that V2 divided by R1 into R3 divided by R1 plus RT plus R2 is series. Similarly, I2 double dash is nothing but, sorry, I3 double dash it is, sorry, I2 double dash is nothing but, this is nothing but I1 double dash, not I2 double dash, it is I1 double dash. This is I1 double dash is nothing but the total current I2 double dash into opposite resistor, that is R3 divided by R1 plus R3. Then you're getting I3 double dash. So now we'll be applying superposition theorem. You know the value of I3 dash and I3 double dash, so that the total current I3 is going to be I3 plus I3 double dash. So this is just a simple circuit I am taking. Network reduction method, you can use any of the method. Here I am just using current divide rules and Ohm's law. If you really want to apply KVL, you can apply KVL and you can get I3 double dash, I1 minus I2, like that. Okay. So I hope you're getting this explanation. So this much of explanation is more than sufficient in the examination to write. So just consider a simple circuit which consists of two sources, either voltage current or voltage or current. You can consider current flowing through any one of the resistor by applying the superposition theorem, by considering one source acting alone and other source will be as zero. Okay. Similarly, you can see the next question. Using superposition theorem, find voltage across the coil with impedance Z equals 3 plus J4 ohm in the circuit. You can see, means that you need to find voltage across this with the help of superposition theorem. V3 plus J4. Before that, you just see it is having more than one source. Two voltage sources are there, one current source is there, so that you have to, it is having three steps. First, you need to consider any of the source. Suppose you can consider 15 at an angle of 25 volts alone. Then this 20 at an angle of minus 30 will be acting as a short circuit, and this current source will be acting as open circuit, so that you can see superposition theorem. V3 plus J4 you need to bind. So now we are considering 15 at an angle of 25 volts alone, so that this 3 at an angle of 50 amperes current source will be open circuit, and 20 at an angle of minus 30 degree will be act as short circuit, so that the circuit which looks like this, current source will be open, so this will be open circuit, and this 20 at an angle of 30 will be short circuit. So now we just apply simple voltage divider rule. Voltage across this impedance, that is nothing but V dash of 3 plus J4 is given by a total voltage V into the same impedance, that is 3 plus J4 impedance, divided by sum of these impedances, that is nothing but 3 plus J4 plus 2 minus J5. So that I'm writing here. Total voltage is nothing but 15 at an angle of 25 volts is a total voltage V. This is V into same impedance, that is 3 plus J4 divided by 3 plus J4 divided by 3 plus J4 plus 2 minus J5. And you keep your calculator in complex mode, and you'll write the value of V dash of 3 plus J4 either in a polar form or rectangular form. So I am writing both answers. In rectangular form, we'll get the answer as 0.143 plus J14.708. If you are converting that into polar form, 14.708 at an angle of 89.44 degree volts. This is first step by considering 15 at an angle of 25 degree volts. Next, you need to consider any one of the source, either current source of 3 at an angle of 50 degree, or else another voltage source of 20 at an angle of minus 30 degree. So what I will do, I'll consider one more source, that is, I'll consider 20 at an angle of 30 degree voltage source. Means I'm considering this current source will be acting as open circuit, and this will be short circuit. So that the circuit which looks like this, again a one series circuit, So V double dash of 3 plus J4. Again, you are applying voltage divider rule. V double dash of 3 plus J4 is nothing but total voltage V. V is nothing but 20 at an angle of minus 30 degree into the same impedance, that is 3 plus J4 divided by sum of impedance, that is nothing but 3 plus J4 plus 2 minus J5. You can see here. Keep your calculator in complex mode again. You can get in a rectangular form as 16.174 plus J is 11.091 volts. After converting this into polar form, you can get V double dash whenever if you are considering another voltage source that is 20 at an angle of minus 30 degree volts. You can get 19.611 at an angle of 34.44 volts. You can check it in your calculator in rectangular form as well as in polar form. So always you're writing the values of voltages and currents in a polar form, but anything is fine. But at the end, the total voltage you should write in a polar form. So now second case is over. Next what? 15 at an angle of 25 degree volts considered, we will be getting V dash of 3 plus J4. After that, you will be considering 20 at an angle of minus 30 degree, you will be getting V double dash of 3 plus J4. So now you need to consider current source, that is 3 at an angle of 15 degree. You need to consider this one. If you are considering this, these two voltage sources will be short circuit, so that the circuit which looks like this. So 15 at an angle of 25 degree volts will be short circuit. Again, 20 at an angle of minus 30 degree will be short circuit. We'll be considering only 3 at an angle of 50 degree, and you need to get V triple dash of 3 plus J4. So V triple dash of 3 plus J4 is nothing but current flows to, that is I1 I am considering, so that I1 into 3 plus J4. So before that, you need to find the value of I1. So to find this I1, you are just simply applying current divider. See, there is a total current and two branches will be having. So that the current divider says as I1, which is given by total current I, that is nothing but 3 at an angle of 50 degree into opposite resistor. So you will be finding current flows to this impedance. So that opposite impedance is 2 minus J5 into 2 minus J5 divided by sum of impedances, that is 3 plus J4 plus 2 minus J5. Can see here, this will get. Again, you keep your calculator in your complex mode, you'll get answer in the form of rectangular as well as polar, whatever it is. Once after getting the value of I1, calculate the value of V triple dash of 3 plus J4, that is nothing but I1 into 3 plus J4. You can get 10.956 plus J 11.441 volts in a rectangular form. Again, after converting that into polar, you can get 15.841 at an angle of 46.241 degree volts. So now we'll be getting all the three cases voltage, I think all three step voltage, by considering 15 at an angle of 25 degree volts, by considering 20 at an angle of 30 minus 30 degree volts, and also by considering 3 at an angle of 50 degree ampere current source. So now we need to add this V dash, V double dash, and V triple dash to get current or else voltage across 3 plus J4. So that the total voltage which is given by V dash of 3 plus J4 plus V double dash of 3 plus J4, then V triple dash of 3 plus J4. So you'll be substituting the values as the rectangular or polar, but at the end you need to write a voltage and current in a polar form. By substituting that in your calculator, you can get answer as 45.970 at an angle of 53.864 degree volts. And this is for 8 marks. So each step carrying 2 marks. Whenever if you're considering the first one 2 marks, 22 marks, 3 at an angle of 50 degree 2 marks, and the total voltage which will be having 2 marks, total 8 marks. Let's go for the third one now. See now here in the circuit shown below, find the value of load impedance such that power transfer to the load is 50% of power supplied by the load. Means they're just confusing you guys. If there is a maximum power transfer theorem, obviously it is having 50% of efficiency. Okay, so that you just need to find the value of ZL, means load impedance. So in case of maximum power transfer theorem, what it says, the load impedance is nothing but a complex conjugate of equivalent impedance or else Thevenin's impedance, complex conjugate. So now the steps to solve this is, first you can consider before finding the ZL. So remove ZL, or else it is, you just open that ZL. If there is a voltage source, short circuit. If there is a current source, open circuit. So it is having only one voltage source, so that you need to short circuit. So that you can see here, ZL is nothing but complex conjugate of ZTH or Z equivalent. To find ZTH or Z equivalent, short circuit this voltage source and open or else remove this ZL, the circuit which looks like this, short circuiting the voltage source, that is nothing but 10 voltage source will be short circuiting, and the impedance or else a resistor which will be always connected across the short circuit becomes 0, so that this part whatever I marked, so this impedance 2 minus Z2 that becomes 0, that will go. So only what it left, the circuit which looks like this now. So this part will go, you can get 5 and 20 are parallel, and this combination is series to 3 plus J5 by removing load resistor and by short circuiting the voltage source, whereas across short circuit 2 minus J2 is there, that becomes 0. Okay, so that Z equivalent is nothing but 5 is parallel to 20, and this combination is series to 3 plus J5. So 5 into 20 divided by 5 plus 20 plus 3 plus J5 can get Z equivalent or ZTH as 7 plus J5 ohm. So they asked you to find ZL. ZL is nothing but complex conjugate of Z equivalent or else ZTH. So complex conjugate of 7 plus J5 is 7 minus J5. So this is the solution of this. I hope you are getting this answers or solutions with respect to the model question paper. Very soon I'll upload the next fourth question of model question paper as well as from module A2 also. So I hope you are understanding the problems and the solutions, like how this is only just for 4 marks. Okay, so keep that in your mind. And it's a tricky problem and it's very easy problem to solve. Okay, so if you're having any doubts regarding this, feel free to write in a comment box. So keep watching and keep waiting for the next video. I'll upload very soon now because everybody is waiting for the examinations. So I'll upload complete solution of model question paper of electric circuit analysis. It will definitely helps to ECE as well as electrical students, so that keep support and try to share maximum and subscribe maximum. Thank you so much. Have a nice day.